All right. 11. Oliver, what'd you have?
For 11, negative cosine squared alpha.
That'll work. Because it's 1 minus sine squared. And you could leave it as 1 minus sine squared. But 1 minus sine squared. Isn't that equal to positive cosine squared?
Oh, really?
Yeah, I think it is. I think it's positive cosine squared. Okay. 12. What'd you get for that one, Ethan?
This won't make sense. I got cosine squared x equals cosine squared.
No. You're right. It didn't make sense. Because you get, oh, no stylus. Okay, so then for 12, we had secant squared of a minus 1. Okay, but it's not in terms of sines and cosines, is it? So to get in terms of cosine, secant is what in terms of cosine? 1 over cosine, right? So it's 1 over cosine squared. And I just changed my a's and b's and whatever's alphas to x's because they're easier, right? So you could put it like this, or more properly, we multiply this one by cosine squared over cosine squared. We get 1 minus cosine squared of x over cosine squared of x. Okay? You go like that. If you wanted to, you could even go sine squared of x over cosine squared of x. Okay?
Did you write it as tangent?
Nope, because it's supposed to be in terms of sine and cosine. All right. Number 13. That was number 12. 13. We started out with cosine x tangent x plus 1 times sine of x minus 1. What's the first step on this one, Olivia? To get rid of tangent. So cosine x and tangent is what over what? So the cosines cancel here. So it's sine of x plus 1 times sine of x minus 1, which is sine squared of x minus 1. Just leave it like that. Now, could you change that to negative cosine squared of x? Yeah, you could. It's fine for right now. Just so you know how to start manipulating these, that's the biggest part of this assignment. 14. 1 plus cosine of b times 1 minus cosine of b sine of b, or cotangent of b sine of b. Okay, 1 plus cosine of beta, 1 minus, what we change cotangent into, Trey? Where's your note card? Come on, Trey. So what is cotangent the same as?
Is 1 over tan x or cos x over sin x.
How about cosine of
Sure.
over sine?
Yeah, that's what I want.
So then our sines cancel. So we have 1 plus cosine times 1 minus cosine, which is 1 minus cosine squared. And if you wanted to change that to sine squared, you could. Okay? All right, 15. We have 1 plus cosine of alpha tangent of alpha cosecant of alpha over cosecant of alpha. All right. What should I change tangent of alpha into, Matthew?
Sine over cosine.
What should I change cosecant into, Colby? 1 over sine. And then cosecant down here is 1 over sine. So then what happens is the cosines cancel, the sines cancel. On the top, I get 1 plus 1. On the bottom, I have 1 over sine. So I take both the top and the bottom by sine. So I get 2 sine of alpha. (16) We have cosine of x tangent of x plus 1 sine of x minus 1 over cosine squared of x. All right, so what do I change tangent into, Aspen? So the cosines cancel, and so we get sine squared of x minus 1 over cosine squared of x. Sine squared of x minus 1 is what? Negative cosine squared of x, which negative cosine squared over cosine squared is negative 1. Everybody agree? All right. So those were the first few problems. Then the last 6 were putting things in terms of each other. So the first one was putting cotangent in terms of cosecant. I know that cotangent squared of x plus 1 equals cosecant squared of x. What do I do to each side to get cotangent alone? First step, subtract 1. And then take the square root. So cotangent of x equals the square root plus or minus the square root of cosecant squared of x minus 1. That is the answer we want. 18, secant in terms of tangent. I know that secant squared of x equals tangent squared of x plus 1. So first thing I do here is just take the square root of each side. And I'm done. So the first two were like easy peasy lemon squeezy. 19. On 19, sine of x in terms of cotangent of x. Now, is there a Pythagorean identity with both sine and cotangent in? No. What's the trig identity? What's the Pythagorean identity with cotangent? Cosecant. Now, can I turn sine into cosecant? Yes. So, I know that cosecant squared of x equals cotangent squared of x plus 1, correct? And so cosecant squared is 1 over sine squared. So if I take the reciprocal on both sides, and then take the square root of both sides, sine of x equals plus or minus 1 over the square root of cotangent squared of x plus 1. If we leave it like that for today, that's fine. This is not the most important thing in the world, but it's so you can kind of relate things back and forth a little bit. So these 6 problems won't appear on a quiz or a test. So you don't have to worry about that.
How does like, I don't get how cotangent squared x plus 1 becomes 1 over cotangent squared x plus 1.
See how I have 1 over sine squared here? When I flipped over this side, I have to flip over this side.
That's crazy.
Yeah. Took the reciprocal of both sides. Going to do that on the next problem too. Cosine in terms of tangent. We know that cosine and tangent are in the same Pythagorean identity. Secant squared of x equals tangent squared of x plus 1. What is secant squared the same as? 1 over cosine squared of x. So I'll reciprocal each side. Take the square root of both sides. Square root of 1 is 1 over the square root of tangent squared of x plus 1. And I'm just going to leave it on the bottom for now. 21. Tangent in terms of cosecant. Are tangent and cosecant in the same Pythagorean identity? No. Cotangent and cosecant are in the same Pythagorean identity. Tangent and secant are. Now, what's easier to turn into something? Is it easy to turn cosecant into secant, or is it easy to turn tangent into cotangent? Tangent into cotangent. So what I'm going to do is say, well, cotangent squared of x plus 1 equals cosecant squared of x. So cotangent squared of x equals cosecant squared of x minus 1. So cotangent squared is 1 over tangent squared. Flip both sides. So if I take the reciprocal of both sides, and then square root both sides, tangent x equals 1 over plus or minus the square root of the cosecant squared of x minus 1. And then finally, cotangent in terms of secant. So tangent squared of x plus 1 equals secant squared of x. So tangent squared of x equals secant squared of x minus 1. Flip, or take the reciprocal, 1 over cotangent squared of x equals secant squared of x minus 1. So if I reciprocal both sides, cotangent squared of x equals 1 over secant squared of x minus 1. Square root cotangent of x equals plus or minus 1 over the square root of secant squared of x minus 1. All right. Now, if you want, you can use these to figure out values. Okay? And that's what we're going to do today, is figure out values of trig identities in certain quadrants. All right. So, back earlier this year, if we had a point like 3, 2. If you had the point 3, 2, we could draw a triangle and figure out what the sine, cosine, tangent, secant, let's go cosecant first. Cosecant, secant, cotangent was of those points. Okay? What we did is we said, well, this is 3, this is 2. Did the Pythagorean theorem, c squared equals a squared plus b squared. So c squared equals 9 plus 4. C squared equals 13. C equals the square root of 13. And then we started writing opposite over adjacent, blah, 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 blah. Okay? We're not going to do that today. Okay? We're going to take the same type of principle, and instead of drawing out a triangle to do it, we're going to use trig identities to do the same thing of figuring out that, tangent is 2/3 and cotangent is 3/2, and this is 2 square root of 13 over 13, and so on. We're going to use trig identities. So let's say we know that the cosine of x equals 5, 6 in quadrant 1. I want to find the other 5 trig identities, or the other 5 trig functions using trig identities. Now, every trig function has a reciprocal. So the easiest one to find is its reciprocal function. We already have cosine, so we can skip over that. Sine, tangent, cosecant. Come on, Mr. Bierschbach. Cosecant x, secant x, cotangent x. All right. So which function is a reciprocal of cosine? Secant. So we know right off the bat secant is 6/5. Boom. Got that one done. Okay. Now I know both cosine and secant. To figure out sine, I can use a Pythagorean identity. So what's my Pythagorean identity? Well, I know that sine squared of x plus cosine squared of x equals 1, right? So if I know that, I can say sine squared of x plus 5/6 squared equals 1. What's 5/6 squared? 25/36. I'm going to change 1 into 36/36. So that's easier to subtract. What's 36/36 minus 25/36? 36 minus 25 is 11/36. To get it alone, take the square root. I got sine done. Once I have sine done, what's the easiest one to find after that? Before cosecant. I know that the cosecant is a reciprocal of the sine. Can I leave square root 11 on the bottom? No. Multiply top and bottom by square root 11. So it's 6 square root 11 over 11. Okay, what can I find next? Let's do tangent. Now, you know tangent is sine over cosine, right? So tangent of x is square root 11 over 6 over 5/6, right? What do I do? Multiply by 6 on top and bottom. So the tangent of x equals the square root 11 over 5. That one's done. What's the only one left? Cotangent. Cotangent is 5 over the square root of 11. Multiply top and bottom by square root of 11. So it's 5 square root of 11 over 11. And I bet if we would use a triangle to figure all that out, we'd get the same answers. So what I'm showing you is there's more than one way to do trig, but now we're using trig identities to figure out some of that same information we found earlier this year. Okay, let's do another one. Okay, that time we were in quadrant 1. Everything in quadrant 1 is positive, so it makes life easy. If we're in one of the other quadrants, you have to pay attention to this chart. Like if we're in this quadrant, sine, cosine, and are both negative, tangent is positive. So let's say that my screen flips around all crazy weird. Let's say that the tangent of x equals 3/4 from pi to 3 pi over 2. What does that mean? Well, this tells me where I'm at. What quadrant would this be in? Pi, 3 pi over 2. X is somewhere in between there. That would mean I'm in quadrant 3. All right, So sine of x, cosine of x, cosecant of x, secant of x, cotangent of x. What one would be the easiest one to find out of all these? Cotangent of x is 4/3. Cotangent of x is 4/3. Okay, what Pythagorean identity does tangent share itself with? Secant. I know that secant squared of x equals tangent squared of x plus 1, right? So secant squared of x equals 3/4 squared plus 1. Okay. Okay. What's 3/4 squared? And 1 is 16/16. So 9 plus 16 is 25/16. Which, if we take the square root of each side, secant of x would equal 5/4. But not so fast, my friends. Does secant of x equal 5/4? It equals a negative 5/4 because we are in quadrant 3. Because when you take a square root, it's a positive or negative. And so depending on where we're at, because we're in quadrant 3, it is negative. Once I find secant, what's super easy to find? Cosine. Cosine is negative 4/5. Okay. Now I got to find sine somehow. How can I find sine? Well, I know sine squared of x plus cosine squared of x equals 1. So sine squared of x plus negative 4/5 squared equals 1. Sine squared of x plus 16/25 equals 1. Or 25/25. If we subtract 16/25 from each side, I get 9/25. So sine of x must equal 3/5, and it's negative. So cosecant would be negative 5/3. Okay, we good? Could you do 6 problems like this? Good, because you're going to. Page 165. Numbers 23 through 28 all. You feel fear?
I know you as numbers gonna pop up